If you understand the question, no, there is nothing difficulty it will be. So there is a let us see complicated question. A uniform bar of length 6a, therefore total length is how much? No, 6a. Mass is how much? No, 8 m. Mass of this one, no, totally 8 m. Lies on a smooth floor like this. It will be lies onto this. Right? There is a 2 point masses of m and 2m. Therefore this is m and 2m are moving with the horizontal plane. Therefore v and 2v. This diagram is shown. And stick to the bar after the collision. No. Calculate the velocity of the center of mass first, and angular velocity about the center of mass, and total kinetic energy just after the collision. Clear? There are 3 questions are there in this one. No? So first you should understand this question here, no, very clearly. So there is a one rod is there now. This is totally 6a. Everything is there in the diagram now. Therefore this is 2m going with a speed v, is hitting at this point 2a distance, no. So this is how much now? This is m 2v going on to this, hitting on to this one now. Therefore when it is hitting like this, what will happen now? This one now, if suppose this momentum is greater, this compared to this one now, therefore this object would have moved like this, right? If this momentum and this momentum both are same, no, therefore this will not experience any force, no, therefore it will be able to rotate. So now definitely it will rotate, no, but whether it will move or not, no, we have to see it, no, right? So then if it is rotated is there, so we will have a rotational kinetic energy. If it is having motion, translator motion is there, translational kinetic energy and rotational kinetic energy, both you have to calculate. First of all you have to check it whether it is undergoing like a translator motion or not. Translatory means momentum, rotational means angular momentum, right? Translatory means force, right? Rotational means torque. Clear? Keep in mind. So translator, first of all you have to calculate velocity of the center of mass, total body of this one. So therefore what you have to calculate? You have to calculate the conservation of momentum. So what is the momentum here now? Initially this rod was not moving, first one, no. So conservation of linear momentum. Linear momentum. So that means total initial momentum and final momentum, right? Right? We will test the conservation of linear momentum now. So therefore total before initial momentum and therefore final momentum now, final linear momentum. So initially this rod was not moving, rod momentum was 0, and this momentum is having how much now? 2m into v, but it is going in this direction now. Suppose if you take it as this direction now, so this is minus j cap. Clear? And this is going plus m into 2v, but it is going upward, therefore it will be plus j cap. So this rod was not moving, therefore now finally it is moving. What is it moving now? Therefore 2m, mass of this one is getting stuck to this one, no? Plus m plus rod mass is 8m into velocity. After this one, no, what will be the velocity? So surprising result, 2mv minus j cap, 2mv plus j cap, no. So minus j cap plus 2mv j cap, therefore it is 11m into v, velocity of the center of mass. So this it will becomes to the 0, 11mv. So velocity of the center of mass, it will becomes to the 0. That means velocity of the center of mass is becoming to the 0, means what? This rod is not moving, no translatory motion, no translatory motion. No translatory motion means what? Kinetic energy. Kinetic energy due to translational is also 0. Therefore it is not moving, right? So but it will rotate. Let us see now. Now, so for translatory linear momentum conservation, no, for rotational angular momentum conservation, no, right? Let us see. So how angular momentum now? Let us see in this one, no. So now net torque, right? So second one, no, conservation of angular momentum. Clear? Conservation of angular momentum. So angular momentum, what it will do now here, therefore initially this was not rotating, total initial angular momentum, total final angular momentum now. Initial angular momentum, so this rod was not rotating now, initially angular momentum was 0. But therefore this, what it is doing now, this 2 mv momentum is how much now? Therefore 2 mv, but what is the perpendicular distance? It is a, but this 2 mv, what it is doing now? This 2 mv, suppose here this is now, this 2 mv is comes and hit onto this. So here, see here, if you are hitting onto this, this rod is rotating like this. And this part, no, therefore this also hitting, no, is hitting like this. So this also it is making the rod to rotate. Therefore both are acting in the same direction now. Therefore here 2 mv right. So 2 mv into perpendicular distance is nothing but a. So therefore it is rotating like this. This is making to rotate like this. Clear? Anti-clockwise. And this also is making to rotate like this, no? Plus this is m into 2m. Therefore 2 mv. Also perpendicular distance is how much, no? Perpendicular distance is nothing but a 2a. Clear? It will be equal to, right? So therefore it will be rotating. What is a moment of, what will be your angular velocity here now? So that is nothing but a I omega. What is the I? Therefore your rod is rotating now. Therefore it is rotating at the center here now. Center means ml square by ml. L is what? L is nothing but a totally, it will be totally 6a whole square. Therefore total mass of this one is how much now? 8m divided by ml square by 12 plus this mass. Therefore 2m is getting stuck to this one, no? 2m into distance is how much, no? That is a square plus this is mass is how much, no? M into distance is how much, no? 2a whole square. This it will be your moment of inertia into omega, I omega. Clear? So therefore this how much now? It will be 2 mva, 4 mva, 4 plus 2, therefore 6 mv into a, it will be equal to, therefore here 4 2s are, therefore 4 3s are. So this one you can rewrite it as, this is 2 into 6a into 6a divided by 3 plus, therefore 2ma square plus 4ma square into omega. Let us simplify this one, no? Right, 6mv into a, it will be equal to 3 1s are, 3 2s are. Therefore here it will be 4, 24a, 24 plus 6 no. That is nothing but a 30. 24 plus 6 no, 30. Right? 30, sorry, here it will be 2m. 30 ma square into omega. Clear? So therefore here what you can write now, 6 1s are, 6 5s are. So this m and m get cancelled out, no? So this and a get cancelled out, no? Omega it will be equal to, therefore v by 5. This is a 5a. So this it will be your angular velocity of this one. Clear? So now we want to calculate, it is having angular velocity, but therefore it will be having total kinetic energy. Total kinetic energy means what? Rotational kinetic energy will be there. So what will be the rotational kinetic energy? So here kinetic energy, it will be equal to half. What will be the moment of inertia? What we got it now? 30 ma square we got it now. This is simplified, no? therefore 30 m a square into, therefore here omega square is nothing but a v square by, so 25 a square. This will get cancelled out, no? So this it will be the 15, 5 3s are 5 5s are, therefore 3 by 5 mv square will be your kinetic energy of this rod. In this way, see, one by one question now you need to understand, then you can solve very easily onto this. Clear? So in this way we can solve the problems, no?